Now that we have a basic understanding of how this is going to play out and the overarching idea behind it, namely we're going to try to prove that parameters have changed based off of data, either because our sample data is far away from the group or our sample data has a very low probability of happening by random chance. Those are the two methods. We need to go back and kind of get more formal now. So if you look at the appendix, you can see that step one for these hypothesis tests, I mean, you don't know what the rest of the stuff is, but step one is always talking about null and alternative hypotheses. And let me scroll down here. Oops, see, step one, determine the null and alternative hypotheses. While I'm on the subject, by the way, those requirements up there should be looking very familiar because that's what we covered in chapter 8, right? And also we ran into those again in chapter 9 as well. There's just some slight modifications, but you can follow these pretty much to the letter. All right, so let's look at the null and alternative hypotheses in depth. That's what the next couple pages are about. So the null hypothesis is H naught, as in all for naught, N-A-U-G-H-T, naught. But if you want to just say H sub 0 or H0, H naught, everybody knows what you mean, right? So it's the null hypothesis. It's a statement of no change, no effect, or no difference in the population parameter of interest. It's what you assume to be true unless you can prove it otherwise. So you assume when you pick up my die that P is equal to 1/6. You assume certain things about the world, and that means since it's assumed and it's always no change, no effect, no difference, that means that H0 will always be equals. Always, always, always have an equal sign. Okay, now the alternative hypothesis. In our book, it's H1. Some books will call it HA, so A for alternative. Either one is fine. It's a statement that claims there is some change, either more or less or different in that population parameter. And running this hypothesis test is a little like running a trial. So you start by assuming that the null hypothesis is true, you gather evidence, and either you reject that null hypothesis or not. And determine whether you believe the alternative may be true. Right? We never know for sure, but we think it might be based on evidence. Now the potential parameters for hypotheses, and there should have been a few blanks here, but it's from the previous page. The population mean, mu, the population proportion, p, and then the population variance or population standard deviation. Sigma squared is the variance, and sigma is the standard deviation. Okay, now there are three types of tests that we can have, especially in chapter 10, which is the right-tailed, the left-tailed, or the two-tailed test. So the left and right-tailed are each actually one-tailed tests because they only go off in one direction. So the right-tailed only goes to the right, and then the left-tailed only goes to the left. And then two-tailed obviously is both tails. Okay, so if I was doing a right-tailed test, some of the words that I might spot in the problem that'll cue into me that this is a right-tailed test would be things like increase, go up, rise, exceeds. So let me write some of these words in for you. Right, pick your synonym for increase because there's just tons and tons of them, but that's what you're looking for. You're looking for words that are going up. So increase, go up, rise, exceed, grows, gains, raises, surges, boosts, all of these words. They're all meaning growing, greater than. So let me give you an example real quick. Suppose I say that the variability on stats exams is 8 points, and you say, no, 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 you don't know what you're talking about. It's more than 8 points, right? Or 8 percentage points or something like that. That would be, a greater than. There we have it. So is the standard deviation higher than expected? Oh, that gives me another word, more and higher. Higher, more than, etc. There we go. Got some more words in there. And it's not a bad idea to have these keywords, first of all, on your note sheet, definitely for your exam, but also add to them. So when you run into problems that use a different word than you've seen before, go back here or go back to your note sheet and start writing more of the words in, because there's lots and lots and lots of them. Okay, so next, what about a left-tailed? Well, it'll be all the decrease words. So decreasing, going down, etc. There, I couldn't think of as many words for that one, but so decrease, not increase, decrease, go down, sink, decline, lower, less than, etc. They all mean a left-tailed test. So for example, most students think that the average human body temperature is 98.6 degrees Fahrenheit. But I'm here to tell you that I don't think so. I think it's actually lower than that. And that would be a mu because we're talking about the average body temperature. So the average body temperature is lower than 98.6 degrees, or so I will have you believe by the time we reach a problem like that in chapter 11. And that would be the null and alternative hypotheses. Now notice for every problem here, I'm actually putting in the H0, the H1. They're followed by colons, not equal signs. That has to do with the logical symbology if you take a logic class. So it's H0 colon mu equals 98.6. The null hypothesis always has the equals, and the alternative is always where a direction is. So going up is right-tailed, going down is left-tailed. The two-tailed test could be one of the harder ones to spot, but for two-tailed, you want to look for words like changed or different. Not is a big one. It's not this anymore, right? Well, then what is it? It could go either direction, left or right. So gone up or down, or this has had an effect, but it's not giving you a direction of which way it's had an effect. That's a not equal to. So for example, our dice not being not fair, not, right? Not fair is N-O-T, not. So it could be not equal to 1/6, and we don't have a decision about which way we think it's going to go. Now, it's very important to notice that you don't look at your sample data to make that decision. You actually make your decision ahead of time of what you want to test, and then your sample data is used to test against that. So you decide whether you want to go in a particular direction, less than, greater than, or if you just want to do not equal to.